Differentiation rules. In this video we'll go through the various rules related to the derivative of a function. The first one we will go through and have a look at is the power rule. So let's do an example. F of x equals 7x cubed plus 2x squared minus 6. Remember, each term in the function is treated as a separate function. So f dash of x equals, multiply by the power, so 3 times 7 is 21, take 1 off the power, x squared, plus 2 times 2 is 4, take 1 off the power, becomes x. A constant just becomes 0. A second, f of x equals 1 over 3x to the 5. In order to use the power rule, bring the power to the top and make it negative, so we get x to the power of minus 5 over 3. So f dash of x equals, multiply by the power, so we get minus 5, take 1 off the power, it becomes minus 6 over 3. Now let's take the power back to the bottom, so we get minus 5 over 3x to the power of 6. Number 3, f of x equals 4 root x. Remember that root x is x to the power of half, so we've got that's equal to 4x to the power of half. Therefore f dash x is equal to half times a 4 is 2, x to the power of minus a half, which is equal to 2 over root x. Because x to the power of half, you can take it to the bottom and it becomes root x. Chain rule. The chain rule is used when you have a function within a function, such as f of x equals 3x plus 4 to the power of 6. So f dash x, bring down the power, 6, bracket remains the same, take 1 off the power, and then multiply by the differential of the bracket, which in this case is 3. So f dash x is equal to 6 times 3 is 18, 3x plus 4 raised to the power of 5. 2. F of x is equal to 3x squared minus 6 raised to the power of 4. So f dash x will equal, bring down the power, 4, bracket remains the same, 3x squared minus 6, take 1 off the power, 3, and then multiply by the differential of the bracket, which is 6x. So f dash x is equal to 4 times 6x is 24x, 3x squared minus 6 to the power of 3. Number 3, f of x equals e raised to the power of 2x. So f dash x will equal 2 e to the x 2x. Number 4, f of x equals e raised to the power of x squared plus 1. So f dash x is equal to the differential of the power, which is 2x, times e to the power of x squared plus 1. And number 5, f of x is equal to natural log of 2x plus 1. So f dash x is equal to 1 over 2x plus 1 times the differential of the bracket, which is 2. So f dash x is equal to 2 over 2x plus 1. The product rule. The product rule states that if a function y is equal to uv, where u and v are two functions, then the differential dy over dx is equal to u times the differential of v plus v times the differential of u. Number 1. If f of x equals 3x squared e to the power of 2x, u is equal to 3x squared, so then the differential u dash is equal to 6x, v is equal to e to the power of 2x, so the differential v dash is equal to 2e to the 2x. So f dash x is equal to the first, 3x squared, times the differential of the second, 2e to the 2x, plus the second, e to the 2x, times the differential of the first, 6x. So f dash x is equal to 6x squared e to the 2x plus 6x e to the 2x. If you factorise out, you get f dash x is equal to 6 e to the 2x x brackets x plus 1. Number 2. F of x is equal to x sine x. Therefore, u is equal to x. So u dash is equal to 1. V is equal to sine x. So v dash is equal to cos x. So f dash x is equal to the first, x, differential of the second, cos x, plus the second, sine x, times the differential of the first, 1. So f dash x is equal to x cos x plus sine x. And number 3, f of x is equal to sine x e to the power of x squared. So u is equal to sine x, so u dash is equal to cos x, v is equal to e to the power of x squared, so v dash is equal to 2x e to the power of x squared. So f dash x is equal to the first times the differential of the second, which is 2x e to the x squared sine x, plus e to the x squared cos x, which when you factorise gives you f dash x is equal to e to the power of x squared brackets 2x sine x plus cos x. Quotient rule. The quotient rule states that if y is some function u over v, where u and v are functions, then dy over dx is equal to v times the differential of u minus u times the differential of v all over v squared. Number 1. F of x equals x squared plus 2 over e to the power of x. Therefore, u is equal to x squared plus 2, so u dash, its derivative, is equal to 2x. V is equal to e to the power of x, and v dash, the derivative, is equal to e to the power of x. For f of x is equal to the bottom, e to the x, times the differential at the top, 2x, minus the top, x squared plus 2, times the differential of the bottom, which is e to the x, all over the bottom squared, which is e to the x squared. If you factorise out the top, you get f dash x is equal to e to the x, brackets 2x minus x squared minus 2, all over e to the x all squared. Now cancel top and bottom, you get f dash x is equal to e to the x, brackets minus 2 plus 2x minus x squared. Number 2, f of x equals sine x over cos x. Therefore, u is equal to sine x, u dash is equal to cos x, v is equal to cos x, v dash is equal to sine x. Therefore, f dash x is equal to the bottom, cos x, times the differential of the top, cos x, minus the top, sine x, times the differential of the bottom, sine x, all over the bottom squared, which is cos x all squared. Therefore, f dash x is equal to cos squared x minus sine squared x all over cos squared x, which when you tidy it up is equal to 1 over cos squared x, which if you note, sine over cos is equal to tan, so the differential of tan is minus 1 over cos squared